Howdy, AP PreCal. It is Ms. Kosh. These are the notes for section 2.1 and 2.2 for AP PreCal. I kind of I did part of this first page is part of 2.1 and 2.2, and then with arithmetic or linear sequences. Arithmetic sequences and linear functions, and then the second part becomes geometric sequences and exponential functions. And you'll notice that the two pages kind of mirror each other in format. So hopefully this is a clear way to do it, and hopefully it makes sense to you. All right, so successive terms in an arithmetic sequence have a common difference or a constant rate of change. You should know at this point, as soon as you see a constant rate of change, you know that's what type of function. If you don't know, go back and watch all my videos. No, but it's linear. Okay, so there is said, given the sequence, -10, -4, 2, 8, 14, find a sub 1, so the very first term is -10. Find D, the common difference. What am I doing? I am adding 6 each time, and a sub n. So with, what I might notice here, a sub n is equal to, I have a slope of 6, but if I plug in 1, I want to get -10, so I have to do -16. I can help you make more sense of that as we keep going. Okay, but now what we want to do, and I have formulas right here that are easy to work or helpful to work with, but I hadn't quite taught them yet. So on this one, what they want you to do is what we notice is this -10 can be described as having an input value of 1 and an output value of -10. This is the first term of our sequence. The second term of our sequence would have an input value of 2 and an output value of -4. Or we could say a sub 1 equals -10. We could say a sub 2 equals -4. Okay, so now I want to plot those, and this was easier to do when I was doing the homework on the iPad. When I was making my answer key, we have our input values are the term of what term of the sequence is it, and so we have 1, -10, and then 2 should be at, I think this is at -4, and then 3 was at 2, so that looks about here. 4 was at 8, so here's 5, 6, 7, 8, and then 5, the fifth term of the sequence, was at 14, which is right here. You may notice a couple points that we want to make here. These points all fall on the same line. Okay, so this arithmetic series, I lied. They took series out of the curriculum. I'm going to teach it at the end of the year anyway. The arithmetic sequence is what I meant to say, is gives us particular points on a line. Okay, it's if you remember from the previous the notes that I did last class, we said that the PreCal book defines a sequence from the whole numbers to the real numbers. So every input value is a whole number. So you can't, if I say plot this sequence, you can't give me a solid line because it's only particular points of that. All right. The general term of an arithmetic sequence with a common difference D is given by the following and can be related to a linear function. Okay, so these two are kind of AP style, and this is just what Ms. Kosh really likes. So I'm starting to work in the way of, I'm starting to think a little more like AP, but this is how I have taught it for years and years and years. Let's talk about what we've got here. A sub 0 is our initial value. And this would correspond to the y-intercept. Okay, so this is what you would have. We didn't actually have a point right there, but if I had taken this out and found out what that value was, that's that initial value. It's the y-intercept. It's the b value if our equation is y equals mx plus b. That's the y-intercept. It's the initial amount. Okay, then we also will see this a sub n, and that's the value of the nth term. Maybe I write down more than what I'm saying, but I'm just being quick. Okay, a sub k would be the value of the kth term. And what else do I have? Okay, D is the common difference. And And any other variables I need to define? I think we're good. Okay, so let's look at this a little bit more. Let me see if I can make this make a little more sense. If I have the first term, the second term, the third term, the fourth term, the fifth term, and somewhere out here, dot, 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 I don't know, anyway, I don't know why I drew a dash. Somewhere out here I have the nth term, okay? What if I want to, if I go from to get to from A1 to A2, I have to add the common difference. If to go from A2 to A3, I add the common difference again, and so forth. So notice if I want to go from the first term to the fifth term, I have to add my common difference 1, 2, 3, 4 times. Okay, so what I just told you here is that A sub 5 would equal A sub 1 plus 4 times that common difference. Okay, what if I want to get the 10th term and I know the first term? Well, hopefully you realize that I would have to add that common difference 9 times. Okay, try this. What if I say I want the 20th term and I know the first term? Do you have an answer? Hopefully you do. Okay, I feel a little cheesy saying that, but there we go. We're going to have to add that common difference 19 times. So what am I doing? I'm taking, to find my nth term, if I'm starting at my first term, I would have to add my common difference n minus 1 times. And that's the version of the formula that I have liked for years and years. AP PreCal does it slightly differently. They would say, okay, if you want the nth term, but you're at the 0 term, so a term we don't even list in our sequence, like if I say what's the first 5 terms, you would not include this, okay? Then what we have to do is, well, what you're doing is you're starting back here. So if I'm starting here and I want to get to the 5th term, then I have to add my common difference 1, 2, 3, 4, 5 times. And so this would be 5 times the common difference, but I think they write it this way. I think they say A sub 0 plus D times n, but hopefully you agree that those are equivalent. So this function right here, A sub n equals A sub 0 plus dn, corresponds to the equation y is equal to, here's the y-intercept, the initial value, plus d corresponds to the slope, and then the term number corresponds to the let me try this again. What term it is, the term number, like the first term, the second term, the fourth term, whatever, corresponds to the input value, which was x. Okay, we also like to say, well, what happens if I am, okay, let's say A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, A sub 6. Let's say I'm A sub 7. Let's say I'm at the 3rd term and I want to get to the 7th. My brain jumps to the answer. If I'm at the 3rd term and I want to get to the 7th term. So if I have A sub 7, I want A sub 7, I have A sub 3, I have to add the common difference how many times? Well, 1, 2, 3, 4 times. Well, how did I get 4? Hopefully you see it's 7 minus 3. So A sub 7 would be A sub 3 plus 7 minus 3 times that common difference. Okay? We can use that to say, well, what happens if I want the nth term and I'm at the kth term? Well, if this were the kth term and this were the nth term, then what I'm doing, okay, so I have to add it 1, 2, 3, 4, 5. That was 7 minus 2. This becomes, what was it? N minus k times that common difference. Except they do the d first. Okay, same idea. But this is the formula that they like to use. The reason they like to use this one is because this relates to the point slope formula for the equation of a line, except they're going to tweak it a tiny bit. What they have in the course guide, whatever, is that this is y sub I plus m times x sub I. Okay, so what's happening here, is that right? I think so. Hang on, let's make sure. Basically, we're saying we have a slope of m that corresponds to our common difference. Okay, and that we're going through the point, they would say x1, xi, x sub I, y sub I. I don't know why they used I, but here we go. And so the point slope formula is y minus the y value, y sub I, is equal to m times x minus the x value. And so then we just go ahead and say, well, let's add this to the other side. And this right here corresponds to the formula for a sequence. Okay, so I'm getting more used to this version of the sequence formula, even though I have done this my whole life. Well, not my whole life, but much of it. And I'm getting to like this a little bit better, but the reason they write it this way is so that they can connect it to lines, the equation of lines that you already know from Algebra 1. Okay, let's actually try some problems. It says the third term of an arithmetic sequence, so this would be a sub 3 equals negative 12, and the ninth term, a sub 9, is equal to 9. Find the nth term and the 20th term. Okay, so there's more than one way to attack this problem. One way would be to say a sub 9 is equal to a sub 3 plus 9 minus 3 times that common difference. You'll notice they put the common difference in the front. I don't. I just can't. I'm working on it. It doesn't matter. Okay, so a sub 9, what did they tell us? It's 9. A sub 3 is negative 12 plus 6 times the common difference. Add 12. When I divide, I get 21 over 6, which reduces by 3. So D, my common difference, is 7/2. Okay, and so now I can find my nth term. We could use either a sub n or a sub 3 or a sub 9. Let's use a sub 3. A sub 3 plus, what is this? This would be n minus 3 times that common difference. Well, we know some of these values. We don't know a sub n, that's what we're trying to solve for. We do know a sub 3 is negative 12 plus n minus 3 times, we know our common difference is 7/2. Okay, and so I see a sub n is equal to negative 12 plus 7/2 n, oh, sorry, this is kind of annoying, minus 21 over 2. And so then I ultimately get a sub n is equal to, this is 24 over 2. So negative 24 and a negative 21 is a negative 45. So 7 over 2n minus 45 over 2. Okay, and then they say find the 20th term. All right. Since I need a common denominator, I might not just say that this is 70, because then I'm going to have to multiply it out. This is 140 minus 45 over 2. And so this should be 95 over 2. And that is our 20th term. Okay. You could have also thought of this as an ordered pair. You could have said, well, this is the point 3, negative 12, and this is the point 9, 9, and then found the slope of those two, and then wrote the equation as a linear function. But I wanted to practice sequences because we are studying sequences. Okay, 2 more examples, and I think I'll make a second video for exponential. For an arithmetic sequence, we have b sub 5 equals 13, b sub 9 equals 45, and we're trying to find the value of b 15 minus b sub 13. So we know the b sub 9 would be equal to b sub 5 plus 9 minus 5 times the common difference. Okay, so it's like the nth term and the kth term, and then n minus k times d, or d times n minus k. And so b sub 9 is 45, b sub 5 was 13, that is 4d. Okay, subtract this, I get 32. 32 equals 4d, which tells me that d would equal 8. Okay, so then ultimately we're trying to find b sub 15 and then compare that to b 13. Well, b sub 15 would be equal to b sub 13 plus 2 times the common difference. Well, that tells us that b sub 15 minus b sub 13 would be equal to 2 times the common difference. We just found the common difference to be 8. This becomes 2 times 8, which is equal to 16. I'll have to go back and look. I may have squared that in my answer key. I'll go check. If I squared it, I was wrong. Okay, because it's 2 times the common difference. We could find the value of these two, but then that's just a harder way to do the problem. Okay, a linear function has a common difference of negative 7 and includes the input-output pair 10, 14. So this is saying a sub 10 is equal to 14. We can do it that way, or we can think in terms of sequences. So a sub n would be equal to a sub 10 plus n minus 10 times that common difference of negative 7. And so then a sub n is equal to a sub 10 was 14 plus, or 70 minus 7n. I put the, since I'd already written a plus, I knew that was going to be positive. And so a sub n is equal to negative 7n plus 84. And so therefore the function, a linear function f of x would be equal to negative 7x, not n. I was trying to write an n, did you see that? Plus 84. That's a mess, but there you go. I think we have done all the math on this page, and come back for the next video and I'll have the geometric one ready to go. All right, like, subscribe, comment, and go practice.